Okay, good morning everyone. Can you all hear me okay? Yes. Now let me start the second session of this data visualization camp. So welcome to Data Visualization Camp Research Week 2023. Now we are going to start the second session, an open source Odyssey crafting data narratives with that. So basically during our first session, Dr. Sandun basically talked about how you can use different data visualization in order to that can be useful for your decision making process. So now and there he basically during his session he used some menu driven things that allows you to get different visual aspects. But now if you want to do your own things, if you want to visualize your own data, how can you take the control of these different visual representations? That's what I'm going to discuss during this talk. So those who don't know me, so let me first introduce myself. I'm Dr. Priyanka Talagala. I'm a senior lecturer in the Department of Computational Mathematics, Faculty of Information Technology. I earned my PhD in statistics from Monash University, Australia. If you want to learn more about my teaching, my research work, you can visit to my personal website, that is prital.netlify.app. And when it comes to my research focuses on statistical machine learning, data mining, and time series and forecasting. Okay, that's all about me. All the materials, even including this slide deck, they are all available if you go to our workshop website. You can use either this QR code or you can use the link datavizcamp.netlify.app. If you go to the website, so this is our website. So here, this is the home page, and if you go to workshop camp, the materials of the other sessions will be available soon. But here, all the materials related to this session, data narratives with R, you can find it under this tab. So this is the slide deck that I'm using, crafting data narratives with R. Okay. Okay. So during this, I'm going to use R and RStudio. Even during the previous session, Dr. Sandun mentioned about R and RStudio, and some students ask how to install that one. If you are not familiar with R and RStudio, if you go to the website, here I have provided two links, installing R and RStudio and also install RStudio. So if you go to that tab, that will give you a guideline to install R, both R and RStudio. And then, so it's like this. Now you might think, okay, we have two things, R and RStudio. What's the difference? So basically, R is the language, just like Python, Java, R is the language. RStudio is just an IDE. So if I simplify it a little bit further, so if you can think R as an aeroplane. So that's what you use in order to go from one location to the other. So that's what actually does the task, the aeroplane. And you can think RStudio as an airport. So it basically gives you a platform that allows you to use R in a very user-friendly manner. So RStudio is an IDE, but you cannot do analysis only using RStudio. It is just an IDE. You need to have the aeroplane in order to go from one location to the other. So that means you always need to install R. Okay, so install both R and RStudio. I'm going to use RStudio that gives us a very easy platform to work with R. Okay, previously Dr. Sanu showed you the RStudio layout. So basically you have different panels that allows you to do things, that allows you to see the plots. So all these information are available in this guide. If you go to the first two tabs, it basically shows you how to install R and RStudio and what are it gives you an introduction to the RStudio layout. Okay, but since our focus here is on data visualization, I'm not going to spend time on that. I'll directly come to the real part of this talk, data visualization, how to do data visualization using R. So now here what you can see is the tidy workflow. In any data science project, you have these tips. So basically, in a tidy data science workflow, first you have to import your data into a programming language. And then before moving to the data analysis part, you have to tidy up your data. This is we call data pre-processing, data wrangling, data munging. All these things try to make your data ready for the analysis. And then after you tidy up your data, after you clean your data, then comes to the real part. So this is where the magic happens. So you have sometimes you may have to transform your data, and then before coming to the modeling process, there's a very important step. You always need to visualize the data. So in data science, in any data science project, data visualization is a very important part. In my next slide, I will highlight the reasons for that. So before moving to the modeling process, you need to visualize your data. Then only you can make a decision regarding the suitable modeling approach. Okay. So sometimes you may have to do some adjustment to your data. If you have lots of outliers, if you have lots of missing values, then sometimes you may have to incorporate a missing value imputation technique before going for the modeling approach. If you have lots of outliers, sometimes it can generate biased results. So you need to make a decision regarding the outliers, whether you are going to ignore them, whether you are going to filter those things and do a separate analysis. You cannot completely forget about outliers. Sometimes these outliers can carry very significant information. For example, if you think about tsunami situation. So there, if you want to identify, if you want to make some decisions related to tsunami activities, so if you think about the typical behavior, majority of your data points will represent the typical behavior, but what matters the most is the tsunami instances. So those are the outliers. So likewise, you cannot just remove the outliers from an analysis. You always need to visualize your data, and that allows you to make very big decisions before moving to the modeling approach. Okay, and then after that you go for the modeling approach, and you have to do it several times, and then after that you come to the communication part. In any research, data communication is a very important thing. If you don't communicate your results, no point of doing your research. So the things that I'm going to discuss during today's session will be very useful for you to complete this task, which is a very important task in any data science project, and also how to communicate your results. This is applicable for any researcher from any stream. Okay, so basically this tidy workflow highlights the different tools available in the R that allows you to do these steps. But now there you can see there are lots of different, there are various tools that allows you to do these different things related to any data science workflow. But during this session, I'm going to focus on the visualization part. Okay, so before coming to the real part, let me first do a few experiments. My first experiment is just to get an idea about the audience, the composition of the audience. This is a very simple, very kindergarten activity, but that allows me to get some idea about the composition of this and the output of this. When it comes to the final output of this experiment, there are no good or bad outputs. Basically, you will be able to do a self-assessment regarding your learning patterns. Okay, so my first experiment is I want you to follow what I say. Okay, so let's do it. I want to pay attention to this side. So touch your nose. Touch your nose, touch your nose, touch your ears, touch your ears, touch your ears, touch your nose, touch your nose. Okay, I think there are lots of, at the very beginning of that shift, I saw that some of you were touching your nose, some of you were touching your ears instead of touching your nose. Okay, so when I ask you to touch your nose, but I gave you the guidance like this. So when I ask you to touch your nose, if you were touching your ears, that means you're visual learners. Basically, you extract information by looking at something, by extracting visual information. That's how you get the first information in order to understand the context. When I hold my ear, but I ask you to touch your nose, then if you change your hand according to that instruction, you are auditory learners. So there are 4 types of learners: auditory learners, visual learners, kinesthetic learners, read-write learners. Basically, this simple experiment allows us to see whether I'm an auditory learner or a visual learner. I saw that some of you are visual learners. You were holding your ear, but some of you change your hand. That means you are auditory learners. So now the visual learners, then I think you know the importance of visual representations. You use that one in order to extract information. And the auditory learners, so our today's session is all about visualization. Then you might think, okay, I'm an auditory learner, I'm in the safe side, I don't want to worry about, I don't want to learn anything from this session. No, all of you are researchers. You have to pass, once you finish your research, you have to pass that, you have to communicate that results to a broader audience. So in your audience, there can be visual learners. So you need to address that audience. You always need to, the inclusiveness is very important. So you always need to think about your audience. You need to think about, okay, how can I give all this, how can I present my results, the research findings to all these different learners. Okay, so the things that you are going to learn during this session will allow you to communicate your results in a very effective manner. Okay, my second experiment. Okay, what you can see here is, here you can see, for this experiment, I'm using a data set called Datasaurus. This is available in R. There's our package called Datasaurus. Okay, so now I think you know the difference between R and RStudio. Then we have our packages. Okay, even during our previous session, Dr. Sandrun used one R package that allows you to get a Shiny app in order to visualize data. So R packages, they are basically, there are some packages that comes with the original installation, and there are some packages where you have to download it from CRAN. So basically, you can think these R packages as mobile phone apps. Now you have, if you think about a smart mobile phone, so you have different apps for different purposes. You have the Zoom app, that's to make video calls. You have the camera, that's to take photographs. You have the weather app, that's to monitor the weather. So likewise, people have developed different packages for different purposes. So now when it comes to mobile apps, sometimes once you purchase a mobile phone, you can see some apps already installed to your mobile phone. But there are apps where you have to download it from the cloud in order to use it. So the same thing happens with the packages. With the original installation, you will get a set of packages, but sometimes you have to install, if that package does not come with the original installation, you have to download it. Okay. And another thing is, if you go to the installation guideline, you will see two words. You have to install a package, you have to load a package. Right? Install, that means it's very similar to a mobile app. You only install a mobile app only once. Once you install it, the next time you want to use it, you just load it. Right? So you don't install it every time you want to use it. So installation of a package, you have to do it only once. And whenever you want to take the functionalities available inside this package, you always need to use the load function. Okay? So these things you will see if you are not familiar with RORStudio, once you go to the installation guideline, you will see those things. Okay, let's come back to the real part. So now here in this Datasaurus R package, in this there's a package called Datasaurus. It contains a very interesting data set called Datasaurus. So Datasaurus doesn't. So basically in this package, you can see there are 13 data sets. They have stored 13 data sets. So here what you can see is the visual representation of the scatter plots of those 13 data sets. Now if I ask you, okay, my question is, which data set has the highest correlation? So basically correlation, I think you are all familiar with the summary statistic, very basic statistic that allows you to see the strength of the linear relationship between X and Y. So which one, from these visual representations, which one has the highest correlation? It basically measures the strength of the linear relationship. Which one do you think that has the highest correlation? Yes? Let me see. How many of you are saying this? How many of you are saying this? How many of you are saying this? Just pick one. How many of you are saying this? Okay, how many of you are saying this? Okay, how about this one? How many of you are saying this one? Okay, it seems like most of you have selected this one, either this one or this one. So you think according to this visual representation, can you see any similar visual representations here? Here we can see the visual representations are they're very different to one another, right? But now when I ask you to think about the strength of the linear relationship, some of you pick either this one or this one. But if you go and check, then I basically, in addition to these summary statistics, I ask R to give me the summary statistics for these 13 data sets. So basically, if I ask the summary statistics for these 13 data sets, if I, for example, now I have x-axis, y-axis, I have two variables. So basically all these data sets, if you think about the Pearson product correlation coefficient of all these data sets, they actually equal to minus 0.06. Now and even if you go and check the mean value of the x variable, it is exactly equal to 54 in all these data sets. Y mean, it is equal to this, even their standard deviations are very similar. So now you can see, when it comes to the visual representation, you have very different representations. But if you go and check the summary statistics, if you just take the summary statistics, then you will think, okay, you have the same data set. They have repeated the same data set. But once you got the visual representation, you can see they are very different to one another. So that's why I told you this is a really important data set. Basically, this is a data set introduced by Alberto, this researcher. This data set carries a very important message. It basically says, never trust summary statistics alone. Now, if you think about when it comes to whenever you do whenever you do a research, you always get data. Now, there are three ways of representing your data: summary statistics, exploratory, and when it comes to exploratory data analysis, you have tabular representation, graphical representation, and summary statistics. Don't just rely on the summary statistics. Always visualize your data. You will see lots of interesting patterns. Okay, so the key takeaway of this data set is never trust summary statistics alone. Always visualize your data. Okay, I think now I have given you enough motivation to the importance of visualizing data. So let's come to the real part. Now the question is, how can I do a proper visualization using R or whatever the language? So basically in this session, I'm going to focus on the R language. The same package is available in Python called Plot9. You can use the same syntax. Okay, so basically now with that I'm coming to a very important topic, grammar of graphics. So this grammar of graphics, this is a really interesting textbook. Basically, this is in this session we are going to learn a tool called ggplot2 R package. So the underlying theory behind that one is coming from this book, The Grammar of Graphics by Leyland Wilkinson. Basically, this book doesn't have, it has nothing to do with R or any other language. Basically, it explains the anatomy of a visual representation. Once you go through this book, you will be able to understand different aspects related to data visualization. And so without reading this book, you can easily learn ggplot2. But if you want to learn more about that, or if you are doing research in this space, data visualization, this is a really good textbook that you can read. Okay, so now with that, so when it comes to R, if you want to do something, there are multiple ways of doing the same thing. Visualization is one such thing. Okay, for example, now in this class, in this session, we are going to learn a tool called ggplot2. But even without ggplot2, you will be able to do some visualizations using some functionalities available in the base R package. Okay, for example, now if you think about the base R package, That's one of the oldest packages in our ecosystem. For example, if you want to get a pie chart, there's a function called pie, and then inside that you just need to pass your data set. And there's a separate function called bar chart, a bar plot, that allows you to get a bar chart. And if you want to get a line plot, there you can use the plot function. If you want to get a scatter plot, you can use the plot function with some changes to the input that you are passing to that function. So likewise, in the base R package, if you want to get a plot, then you have a separate function for that. Now, with that, so that is the capabilities that you can get from the base R package. Now let's see, now I introduce you to the grammar of graphics. Now I actually told you this word, the grammar of graphics. Now let's see what's the role played by this grammar of graphics. And here I think you are familiar with this word, grammar of graphics. Okay, before coming to this one, let's think about the normal word grammar. So when it comes to a language, now if I just compare this with the normal, the language that we talk, so this is like now here, in order to do something, you have a separate function, separate plot feature. So if you want to get a pie chart, then you need to use the pie function. If you want to get a bar chart, you need to use the bar plot. So it's like, now imagine now, if you have, now there are different types of visualization, visual representations. So imagine if you have 10,000 ways of representing data, now you need to have 10,000 functions in order to do these different graphical representations. So now now you have to remember the function names of all these 10,000 functions, which is a very difficult task. It's like, if you don't know the language correctly, if you don't know the grammar of a given language, then what happens is you can still communicate with another one if you can remember the sentences. You can remember different large number of sentences, and using those things you can communicate with another person. But what happens if you know grammar? If you know the grammar of that language, now you don't have to remember these different sentences. You know the rules, then using that one, you can come up with any sentence. You can create your own sentence according to the situation that you have. So that's what we are trying to do with ggplot2. With the base R, you have different plot functions, but now they have different names. So if you want to use the base R functions, you have to remember all these different function names. But now if you move to the ggplot, what happens is you are not trying to remember the names of the functions. You basically try to understand the anatomy of a graph. Basically, according to grammar of graphics, you can explain any of these graphs using 8 layers. Basically, in grammar of graphics, you have 8 layers. This can be a map visual representation. This can be a bar chart, pie chart, whatever you want to visualize. Any of those graphs can be represented, explained using 8 layers. So now today you are going to so that's why we are going to produce graphics, but we are not going to remember any of the specific functionalities. We are going to learn the grammar, the rule of graphics, and that allows you to do different visual representations. And even in the previous session you saw that we had our data, but there were some built-in functions, and there were some menu-driven options, and that allows you to get some visual representations. But there are situations where you have to do some adjustment to the visual representation and so that it can support your decision-making process. So in order to take the full control of your visual representation, this grammar of graphics will help you to do that. Okay, so now, this is basically the grammar of graphics framework. Now we are moving to the tool ggplot2. Basically, GG stands for grammar of graphics. This tool allows you to create visual representations using grammar of graphics framework. Okay. So Hadley Wickham is the main author of this tool. Now this is widely used in the data science community. This package is widely used in the data science community. And Hadley Wickham, he actually started this project as a part of his PhD thesis. And Professor Di Cook is the main supervisor of Hadley Wickham. And they are frequent. Professor Di Cook now, she is at Monash University, and Hadley Wickham is also a frequent visitor to our research group. So we still have some close collaborations with the main developers of this package. Okay, now I'm going to explain. Now you know the motivation. You know, okay, what we are trying to achieve. You are basically trying to understand the anatomy. Whenever you see a graph using these 8 layers, you can describe it. Okay, so now let's come to the 8. Now let me explain these 8 layers separately. Okay, so we have data, mapping, statistics, scales, geometry, facet, coordinate, and theme. So we are going to start from the bottom layer. So basically the very first layer is data. So now in order to create a visual representation, you need data. So that's basically, you are now complete. You are already familiar with the first layer. We have only 7 layers to go. Okay, so whenever you want to create a plot, you need to have data. And that's actually the first layer. So first you need to identify, this can be your research data or the data that you downloaded from the Scopus. So for this session, for the demonstration purposes, I'm going to use this data set, Palmer Penguins data set. So if you are familiar with the IRIS dataset, if you are from the data science community, previously people used IRIS dataset, but now they have introduced Palmer Penguin. This is mainly for the teaching purposes. This dataset has lots of nice, some interesting patterns. So using this, you can explain a lot of interesting techniques, statistics, data science techniques. So throughout this session, I'm going to use this Palmer Penguins dataset. Okay, so now I'm going to explain how to create a graph using ggplot tool. Okay, so now the first layer is our data. Basically, you ask the question which data to plot. So this is how you initiate your ggplot2 call. So basically, if you just type ggplot, this is what you see. If you go to, for example, here, this is the command prompt. If you just, I have already loaded the library tidyverse package. So, and if you just type ggplot, oops, sorry. Okay, so it basically gives you an empty panel. Basically, in the first layer, you identify which data to plot. So if you just put the ggplot call, it just gives you a blank sheet. It's like basically in the ggplot tool, you are mimicking a human being. Imagine you want to draw it in a piece of paper. So once you identify the data set, now you need to have a paper in order to draw your graph. So ggplot2 call gives you a space to plot your visual representation. And then you need to explain, okay, this is the data set I want to visualize. So inside that, there's an input called data. So you pass the name of your data set. Okay, so ggplot good. Still you can see there's a blank plane. I have my sheet. Still, now you have identified the piece of paper that you are going to produce the plot, and you have identified your data. But still we haven't told them what to do with this data. Okay, so here comes then comes the next layer. So first layer we are done, data. Now you need to map, the mapping layer. On the mapping layer, basically we ask the question, what you want to see on the plot. Okay, so mapping, you have to map. Okay, for x-axis, what do you want to plot? For y-axis, what do you want to plot? So here ggplot, so first layer data, then you need to say, okay, how you want to see, what you want to see on this plot. So then you pass this argument, mapping layer. Mapping, now here you have to pass all the aesthetics. Basically, let's say I want to create a scatter plot. Now there are different columns in this data set. I want to see the scatter plot of flipper length and body mass. Okay, so now you say, okay, I want to plot x-axis, this flipper length I want to take the flipper length to the x-axis. I want to map clipper length to the x-axis, I want to map the body mass to the y-axis. Okay, now that you have basically tell them, okay, what you want to see on the paper. But still, you cannot see the scatter plot. Still, I cannot see the data. Then the geometry. Now you need to say this layer, I'll skip these two and then I'll come to that one later. So you identify your data, you identify what you want to see on the graph, and now you explain how you want to visualize it. How am I going to represent this? Am I going to use a dot? Am I going to use a line? Am I going to use some stars? The geometry. How are you going to? You need to think, okay, if I ask you this to do, if I ask a small kid to do this, then you have to give all these instructions. Okay? So the geometry, I want to see the points. I want to represent my data using points. So now you can see I have a meaningful graph here. So now I use this basically in the ggplot, in the Grammar of Graphics framework. You have 8 layers. Using 3 layers, data, geometry, and mapping, you can get a meaningful visual representation. Very easy. All these slides are available on the website. You can easily go and refer to the slides. So now basically here you have passed the data, you have passed the mapping, you have explained the things that you want to visualize, and here this explains how you want the geometry. Okay, and so basically now you can see for that previous graph I use data, mapping, and geometry. So these, in order to produce, now you saw that if you just used only 2 layers, you couldn't see the meaningful graph. You had to use all these 3 in order to produce a meaningful graph. These are the key layers that you need to use. Without having any of these layers, you cannot. This is actually the minimal requirement. It's like you have so many different grammar rules, but using some basic rules, you can come up with a very simple sentence. So using these 3 rules, you can come up with a very meaningful graph. But there are other layers that allows you to improve those aspects. Okay. So in our now in this one, basically I pass data, mapping, and geom points. You can actually do the same thing. You can change the location of these inputs. You don't have to pass all these things inside the ggplot call. So basically you have ggplot, and then plus you can pass geom point, and within that you can pass the mapping. You still get the same thing. You can refer to the slide deck. I have just changed the position of these inputs. You still get the same thing. Okay, because you have considered all these 3 aspects. I somehow have my mapping, data layer, and the geometry. And even you can get the data layer to this geom point. So basically in this ggplot2, in this ggplot API, you basically put layers on top of each other. So you first take from the ggplot call, you take the paper, and then this layer, put this graph on top of that. And not only that, if you can even add multiple layers on top of each other, then you will get a more complex data set. We'll do such things in our coming slides. But basically now in the ggplot2 API, you need to have mapping, geometry, and the data layers. You need to have those 3 layers in order to make a visual representation. Okay, so now in this one you can see you basically have all the points are in black color. But if you want to explain now in this data set, they have collected information for 3 different species of penguins. So if you want to see the distribution of these species, then maybe you can color the points with respect to the species. And so you can even give a separate shape with respect to the species. This is mainly, you normally do these things so that if you get a black and white printout of this one, if you just omit the shape line, if you just give a separate color, and if you print it in black and white, you will not be able to differentiate those things. So a good practice is to assign both a different shape and a color, so that if you have your color plot, then you can easily extract information. But if you get it in a black and white printout, then still you can retrieve that information if you assign a different shape as well. Okay, so likewise now it's not only the X and the Y axis, you can even map colors, shapes under that mapping layer. So now I have given a separate color to these things. And not only that, now here basically I use a categorical variable to give the colors. You can even use a continuous variable and define a subset like this. Basically, I ask it to give a color, a different color to where the for the penguins where their flipper length is less than 205. So now they have given this color to this side. They have given this color to this side. So now whenever you do a research, whenever you produce a visual representation, you always need to think, what's the purpose of this visual representation? What's the key message that I want to pass to the reader? Then based on that, you need to make a decision about the things that you want to highlight in your visual representation. Okay, and another thing is, this is an interesting one. So now you can see in all these things, I have given all my inputs inside the AES. This is basically a short form for aesthetic. I have given all my inputs inside the aesthetic function. That's because now I want to get the data information in order to map them to these different aesthetics. X-axis, Y-axis, color, shape. But let's say you are not happy with the black color. Let's say you have a theme color. If you are going to produce a report to your institute, maybe it's good to go with the theme colors of your institute. Then instead of using black color, maybe you can set a different color. Now there, you just want to set a purple color to all the points instead of black color. Now for that, you are going to set a color. So that means you don't want to retrieve any information from the data set. You just need to give purple color to all the points. So that means you're not going to map anything. You just want to set a color. So you now pass that type of information outside the aesthetic code. In the previous one, I took the information species, that information to decide a color. So that means you are taking data, information contained in the data to give a color. So you need to pass that inside the aesthetic function. And if you just want to set a color, just pass it outside the aesthetic code. Okay, that allows you to set a color. Okay, all these things are available on the slides. Okay, now I told you, so basically now we use the data layer, we map mapping layer, which data to plot, and then finally how we are going to plot it, that is the geometry layer. So basically you must have already noticed that one. I have my first line, and then I have connected them using a plus sign. Then I add the geom point layer. And if you want to add more layers to this one, just use another plus sign. And if you want to see the density of this one, just pass geom density layer. So it's like you add multiple layers on top of it. Okay, so that's the whole purpose of using an add sign. So likewise, you can mix multiple geometries in order to highlight your data. Very easy. Okay. So for likewise, there are different geometries, different ways of representing data. For example, if you want to create a histogram, then there's a geometry called geometry histogram. Then you just need to, and this is aesthetic, then you only need to specify one variable. We create a histogram only for one variable. So likewise, different geometry have their own inputs, specific inputs. The aesthetics, then you don't have to remember all these things. Okay, for the geom point, I need to pass 2 inputs. For geom histogram, I need to pass only X. You don't have to remember any of these things. In R, there's a very easy way to get the support. R is a very well documented language. So if you want to learn more about these functionalities, you can easily get the help page of this one. So basically, for example, now I use geom point. So in order to get the help page of R, what you need to do is take the function name, and in front of that just put a question mark. Question mark function name. If you hit it, it will bring you to the help page. It's very easy to do the self-study. You only need to need a very small guidance at the beginning. And another thing that you can do is, once you go to a help page, go to the last bit of this help page. There you can always, after explaining all these inputs and outputs, they have given some examples. In most of these help pages, they have provided some self-contained examples. So without going through all those explanations, just copy it, and here you need to get that to the command prompt. Now it will show you how to do that. So you can easily learn R. Just go to the help page here, then first observe the examples that they have done. That will give you a quick idea about the functionalities, and then you can go through the description. Okay, so likewise, if you want now, and then so once you come to the geom input, basically these are the things that you need to pass. And then they have given a detailed explanation to all those inputs. So very easy. So each shape has its own specific aesthetic arguments. No need to memorize any of those things. Just get the help page and learn those things. So basically, now I have covered the key layers that are required in order to produce a meaningful graph. Basically, if you have data, mapping, and geometric layer, then you can produce a meaningful graph. So all the other layers are optional, and that allows you to improve your visual representation. That allows you to add more information to your basic visual representation. Okay, before I move forward, any questions up to this point? Okay, so okay, now I'm going to the third layer, statistics. Okay, now here, for example, now when it comes to scatter plots, in order to produce the scatter plot, we first identify the data, then we identify the columns that we want to visualize, X and Y, and then the geometry, how you are going to represent each and every data point. So that's what we did. So in the when you produce a scatter plot, you don't have to have any other information. But think about a situation where you want to produce a bar plot. Now you have your raw data set, but before producing the bar plot, what's the next step that you need to do? Let's say I want to get the bar plot of the species of the penguin. So in order to do that, you need to get the counts. First you need to get that summary statistic. You need to first get the counts of these these three species, and then only once you have that information, then only you can draw the bars. So that's the purpose of the statistics layer. Okay, I'll show you what's the role played in the geom point, but let's start with this geom bar. So basically the statistic layer is responsible for calculating summary statistics for your data. For certain visual representations, you need the summary statistics. For example, in a bar chart, you need to get the counts. So now behind the scene, it uses the statistics layer. So basically ggplot, penguins. Now I want to get the bar plot of the species. I want to fill, so again I'm doing a mapping. I want to fill these bars according to the species color. And then I just pass the geom bar. Inside this, in the default setting, now here I haven't specified any statistic layer. But if you go and check the default setting, basically it uses statistic count. Now in the default setting they have already specified that one, so you don't have to pass it. Even without having that, you get the output. But if you go and check it, basically behind the scene it uses the statistic layer to get the counts. And you can add one more layer if you want to get those counts. Then you have the geom text. If you want to visualize these information as well, then you had one more layer, geom text. Now you need to specify the counts, and this is how you want to see that. Okay, so that's basically, in this plot they have used three layers: data, mapping. Mapping, basically you map species to X. The X is the species is the one that you want to visualize. And geom bar, geometry, how you are going to visualize it? I want to use bars. And what you want to visualize, I want to visualize counts. After you combine those four layers, you get the meaningful visual representation. And likewise, when it comes to any geometry, so now we are familiar with the geometry layer, one of the mandatory layers. Every geometry layer, it has a statistic layer. but sometimes you don't have to specify. For example, now in my previous scatter plot, I used geom points. Basically, the statistic layer is identity. You don't have to do any changes. You don't have to get summary statistics to produce the points. You just you need to mark X value and Y value when you put a point. There you don't have to do a summary statistic calculation. But when it comes to geom bar, you have to get the statistic count. When it comes to geom box plot, you need 5 basic summary statistics. You need the minimum, maximum, then you need the 3 quartiles Q1, Q2, Q3 in order to produce a geom box plot. So stat box plot will take care of that one. So there are plots where you need the statistic layer in order to produce that one. But in most of these things, they have set the default setting. You don't have to worry about. Just use it like this. Geom point, geom bar, it will do the, behind the scene, it uses the statistic layer. I hope it is clear to everyone. Yeah. If you have any questions, please feel free to raise your hand, then we can clarify it before we move into the next one. So basically, again, you can use the help page to learn more about that. But I hope you can understand the difference. So basically, data, mapping, statistics, geometry. Question? Yeah. Okay. So that's a very important question. So here I'm using tidyverse ecosystem in order to analyze data. So one requirement is your data set should be in tidy format. Then you might think, okay, what do you mean by a tidy format? Tidy format means, now if your data set is in tidy format, that means every column represent a variable. All your columns represent a variable. All your rows represent an instant. For example, if you have collected, for a very simple example, if you have collected data from students, let's say you want to see the academic performance of the students of your class. So all the variables, now it can be the gender, the marks they have obtained, the A-level results, their current GPA. So these are variables. So they should come as columns. And the student names, first student, second student, third student, each row corresponds to a student. And then the third requirement is, if you think about a cell value, it should contain only one value. Sometimes now that's where you need that data pre-processing part. Once you import a data set, your first thing is tidy up the data. You have to first arrange your data set in a tidy format. So there the requirement is, you need to have, for each variable, you need to have a column. For each instant, you need to have a row, and each cell should contain only one data point. There can be certain data sets where each cell you have an entry where they have separated them using comma. Now it's very difficult to think whether it's a numeric value or a categorical value. So first you have to prepare your data set. You have to put that into separate columns. Okay, very good question. Thank you. Yeah. Any other clarifications? Okay, let's move to so now I have covered 3 layers: data, mapping, statistics, and geometry. Now I'm coming to the scale layer. Okay, so the scale layer customizes how the values of the mapped variables are represented visually. So now once you identify your data, under mapping layer, you basically think, okay, what you want to see on the graph. What we want to see on the graph. Under scale layer, you think, you are trying to answer the question, how we want to see that. Here, what you want to see on the graph, here scale layer define how we want to see that. Let me explain it using this. So basically, I have X for the x-axis. So basically, the scale layer customizes how the values of the mapped variables are represented visually. So here, X, I have now mapped this variable to x-axis, this variable to y-axis, and for the colors, I'm getting the information from the species, and for the shape, I'm going to get the information from the species. Now, here, what you get is the default setting, default colors, default shapes. I will mention, okay, use a square to this group, use blue color to this group. But let's say you are not happy with this color palette. Now, how can you change these default settings? That's what I told you, how we want to see it. If you want to change this color palette, now that's where you need the scale layer. Okay, so you can take the, so at the moment, if you haven't mentioned, your preferred way of seeing it, then it will basically use its default setting. But if you want to take the control of this, then you can add a scale layer. So here now I ask, okay, I want to give different colors according to the species, but I don't want to see them in this default setting. I want to give my own colors. So now I add the scale layer, scale color manual. So for the values here, columns for the colors here, first you can define a vector of the preferred colors. So first I have defined, okay, there are 3 types of species in this data set: Adelaide, Chimstrap, and Gentoo. So I want to see this group in red color, I want to see this group in blue color, and I want to see this group in dark green. So first you assign a color and just pass as, and you add one more layer saying, okay, now grammar of graphics, you are adding the 5th layer, scale color manual value goes to. Then you get in the different color. Okay, so now you basically, mapping allows you to see answer what you want to see on the graph, and scale layer answer the question how you want to see it. Now I want to see it in this color palette, so I have given that scale layer. I hope it is clear I hope you all can understand the difference. Okay, and then not only that, now here you can even give color these points with respect to a continuous variable. So color, I'm going to give the bill length, so you can see how it changes, and then for the I'm going to give them a separate shape with respect to the island, their location. So now this is what I get with the default setting. But if you want to have them, so likewise you can, so basically scale layer. So now if you just pass it this way, you can see it basically uses its own color palette, default color palette. Color palette is very important. I'll talk about that one in my upcoming slides. Now first let me show you, if you want to give your own color palettes, there are some predefined color palettes targeting different aspects. Identifying the proper color palette is very important. Sometimes you haven't given enough thought to that, but there are so many things that you need to discuss. So here, for example, there's a tool called Color Brewer. Using that, you can get some predefined color palettes. So here, basically, scale Color Brewer. Now here, type palette. So there are 3 types of color palettes. If you want to see all the color palettes available in this R Color Brewer package, just type this one, R Color Brewer, display brewer all, then it will show you all the different color palettes. Now here you have qualitative and divergence and sequential color palettes. So basically now here I have used dark 2 qualitative color palette. So there's a color palette called dark 2. If I pass that one, then it will take the colors of that color palette. Likewise, you can, now just during this session, you will not be able to remember all those things, but be aware that these things exist, because you need to pay attention to these aspects when you produce plots for your publications. I'll talk about that one in a minute. Okay, so now, so there are likewise, people have defined many different color palettes, and this is one color palette that I use quite frequently whenever I publish my journal articles. There's a color palette called Scale Color Viridis color palette. Normally for most of my publications, I use the Viridis color palette. That's because the Viridis color palette, and also there are color palettes even in the R Color Brewer color palettes, they provide different color scales that are robust to color blindness. If you haven't, sometimes you might haven't thought about that one. The color blindness is very important. I have some collaborators where they are color blind, and I have students who are color blind. So if these colorblind people, they cannot see the same color that we see, the normal people can see. Sometimes they cannot differentiate 2 colors. So sometimes you will give your plot in 3 different colors, but the color blind, if they are suffering from this color blindness, then they will see it as one color. So now we need to, with the research, the inclusiveness, whenever you do communicate your results, you have to think about that aspect. So sometimes your reviewer, once you submit a journal article, your reviewer can be a color-blind person. Then if he cannot see the differences, then you will get negative comments if you cannot see the information that you want to highlight. So one way to avoid that one is you can use these color-blind friendly color palettes. Willys or Brewer color palettes are color-blind friendly. So another interesting thing is these color-blind, the one reason for me to use these Viridis color palettes, they are, if you get them in black and white, still you can differentiate those things. So for details and interactive palette selections, you can go to the website, and these color palettes, the reason for me to use Viridis quite frequent in my journal articles is they are even black and white. You can differentiate those points even in a black and white printout. Sometimes these are some requirements. Sometimes if you insert a lot of colorful graphics into your journal, sometimes you have to pay some extra amount. Then you can avoid such things. Then you can put these type of, you can use these tools. Then it doesn't matter whether they print it in black and white. In the printed version, you will have it in black and white, but still you can differentiate the values. And in the soft copy, you will be able to see them in color. It doesn't make any harm to the content of the visual representation. So likewise, you can take, so here basically this is just to highlight the role played by the scale layer. So here I have mapped this variable to X, this variable to Y, species, color, I want to have give a different shape to this with respect to different species. I want to highlight this one with respect to alpha controls the transparency of the points. So likewise, you can take the full control, you can adjust, you can give your own scales, you can give your own values and change the visual, the final output. Okay, so that's basically the scale layer, how you want to see it. Then I'm going to come to the next layer, the facet layer. So basically the facet layer, here facet wrap. So basically under facet layer, what you do is sometimes, now here in this layer, in this data set, I have information from 3 different species, Adelaide, Chinstrap and Gento. Now sometimes you want to make an investigation, you want to get a subset and do a further investigation related to these species. So in such situation, facet layer allows you to create multiple plots, each showing a subset of your data set. Basically, now let's say you want to produce the same plot for different subsets. You want to get a scatter plot for the male students, you want to get another scatter plot to represent the gender, the female students. Then now, if you don't know this layer, what you can do is you first extract the subset, the male subset, and then you generate a scatter plot. That's your first scatter plot, and then again you extract the female group and produce a separate scatter plot. But now with the facet layer, you don't have to do it like that. You just have to pass one more step, facet wrap. I want to get a scatter plot for the 3 subset in 3 different planners, so variables inside that species. Previously, if you just omit that one, this is what you got. You got everything in one single visual, one panel. Once you pass that facet layer, once you incorporate that facet layer, now you can see these 3 subsets in multiple panels. Right? And now another thing that now you can see your Gento, so their behaviors compared to these two groups, they behave quite similarly, but this group is quite different to the others. They have higher flipper lengths, bigger flipper lengths and big body mass. And another interesting thing that you can see is, now when you ask it to give them in multiple layers, you can see they use the same range for the x-axis and the y-axis. But you can easily change those things. If you just pass scales equal to free x, then you will get them in different range. Now you can take the full control of that, right? And so the next one is, so previously I used the facet wrap. So basically it allows you to get multiple plots with respect to the categories of one variable. Now I'm coming to the second one, facet grid. Let's say you have two variables and you want to create multiple plots for these different subsets, define these two variables. Then here you can pass both variables, variable species, variable gender, and now you get a grid. So the same thing with two categorical variables, first one with one categorical variable. And so that basically now we have covered like 6 layers. Now the coordinates layer. So another important aspect that we need to think whenever you produce a plot. So now when it comes to bar plot, in our previous graph, they actually used the coordinate layer. The default, they use the default setting. Basically, whenever you draw a graph, you need to think how the plot's coordinate system is structured. When it comes to bar plots, when it comes to scatter plots, you use the Cartesian coordinate. But if you think about the pie chart, it uses the polar coordinate. So now we are trying to explain the anatomy of any given plot. So coordinate system is also important whenever you try to produce a graph. So for example, now in this one, so if you think about geom bar, if you want to just flip the coordinates, then x and y, then use just coordinate flip, allows you to get it in this way. So basically now you are controlling the coordinate layer. So likewise, there are two types of coordinate systems: linear coordinate systems, non-linear coordinate systems. So linear coordinate systems, coordinate Cartesian, coordinate flip, coordinate flips, and these non-linear coordinate systems are very important if you want to visualize these maps. In your research, if you have to visualize maps, now this is the layer that you need to focus. Okay, you get the longitude, latitude, and then you have to think about how you are going to arrange the coordinate system, and then on top of that you can mark the information contained in your data set. Okay, so the coordinate layer basically control how you are going to plot your data set. Okay, so basically now I have completed all the important layers, 7 layers. We are coming to the last layer, theme layer. So all these previous layers, basically they control the data elements. If you want to control the non-data elements, then that's where you need the theme layer. So basically theme layer controls the non-data elements of your plot. So for example, now there are basically theme layer. So in our previous plots, we saw that all these plots, we could see a gray color grid with white defines. Here we could see gray color. We got these plots in gray color panels, but you can change these panels. Now there are complete themes which controls the non-data display. So basically, if you, for example, if you just plus that, add one more layer theme minimal, now you will get it in a white panel. Now, and then if you want to have it in a dark panel, then you just pass the theme dark layer. So now you can see you have the same information, but the visual, the presentation of the final graph is on the only difference that you can see. So likewise, now there are predefined built-in themes, but if you want to take the full control, then you can define your own things inside this theme. You can control or customize. You can use a customized theme as well. So for example, now this is the one that you get from the normal ggplot2 call. If you use the first few layers, but this is not ready for a publication or a report. You need to give some information, you need to give figure captions, you need to present it in a more meaningful way. So in order to take the control of that, here you can, if you just run this code, this is the final output that you see. So now this graph is ready to put into a publication or a journal article, and which is very more informative than the default one. So basically the theme layer allows you to control the non-data elements. So now that's basically the so now basically in my previous bit, I basically covered the 8 layers. Now you know the 8 layers. Basically, now using these 8 layers, you can explain the anatomy of any graphical representations. So using this knowledge, using this, you can create any graph according to the things that you want to highlight in your data set. Okay, now with that, I'm quickly going through one. I would like to introduce one more thing. Now, all the things that I explained, they are available in the ggplot2 package. But now we know that allows you to get a basic graph. But sometimes you might think, okay, in my research, I want to do I want to do map visualization. I want to do some other time series visualization. So now there are lots of ggplot2 extensions. Now, if you go to this website, you can see if you want to have this type of a graph, this is the extension that you need to refer. If you want to get this type of a heat map, this is the extension that you need to refer. So go to this website. This is available in the slide deck. You will see lots of extensions. Now, in this upcoming slides, I will spend a few more minutes just to highlight some of my favorite extensions. These extensions, ggplot2 extensions, I use quite frequently whenever I write my papers, whenever I prepare my lecture notes, whenever I write a report. Okay, so now all these extensions that I'm going to discuss, they are based on the ggplot2 package, and these authors, they have incorporated some additional features. Okay, so the first one is patchwork for plot compositions. Now you know how to create a basic graph. So let's say now here, this one allows me to get one plot. I have another plot, I have another plot. Now basically I have created 3 plots, right? But now when it comes to certain journals, you have a maximum number of figures that you can put to that journal, or sometimes you have to pay extra money in order to get them published in that same article. So in such situations, one trick that you can do is, if they carry the same information, maybe then you can combine those things and give it as a one single plot. So now you can see I have created 3 different plots. If you want to give it as a one single plot, what you can do is you can use the library patchwork package. So as the name implies, you know, when we were kids, we did this patchwork. Basically, you combine multiple pieces to create one piece. The same thing happens with the patchwork package. These are developers, they always come up with very creative names. So if, for example, now I have my P1 and P3, if you want to have them in the same plot, just put P1 plus P3. Then that will give them, it will produce this type of a plot. Now we have both plots in the same graph. And sometimes in order to save the space, sometimes you need to have them in multiple rows. Then you can use in the same button, you can use basically vertical lines, allows you to put them in side by side, and P3, this slash allows them to get that into the second row. Okay, so now once you pass it in this way, so the same 3 plots, if you pass it like this, then you will get it in this way. But now again, this is still not ready for a publication, because you can see some information that is repeated. So for example, if you come to this one, species, you have the same colors. Species, you have the same color. No need, now you have all these plots in one single graph. No need to have multiple legends in the graph. So you can easily omit that one, P plus plot layout guide collect, that will get you into this. So now you can see you have it in a more meaningful, more visually appealing, you have a more visually appealing plot. And in addition to that, now you need to give a proper figure caption. Then you can add one more layer, plot annotation. You can give a title like this. And sometimes in order to describe the subplots, you need to give this type of a tag. So tag level, then it will give you this type of a tag. So now this is ready for a journal article or a magazine or anything that you produce. So, but you can see you can easily do this by adding just one single line. Okay, so basically now all these functionalities I use, they are available in the patchwork package. But you can see it finally produced a ggplot2 output, ggplot. So if you want to combine ggplot2 functionalities, then you need to combine that. You can add those other layers using this ampersand. Okay, so this is P is now produced from the patchwork output. If you want to add the theme layer, it was in the ggplot2. So if you want to add that one, use the ampersand. And here if you just want to remove the legend position, just say legend position none. Now it will allow you to save more space whenever you put that into a journal. Okay, so that's one package that I use quite frequently that allows me to save the space, and that allows me to address that requirement where you have the maximum number of figures. The next extension that I use quite frequently is the R package called Plotly. So if you are a Python user, you might have already heard about this name. So this allows you to convert a static plot to an interactive plot. Basically, interactive plots allows you to retrieve more information from this type of a graph. So basically now this is the P1, this is the graph that I used, that I created using my ggplot2 package. Now this is a static plot because you can see, I cannot see, and now here you have the X, Y, and the species. But let's say you want to get more information, you want to get a little bit more about this group. What you can do is, you can use the ggplot, Plotly. Inside this Plotly library, there's a function called ggplotly. Now this is my static graph P1, just pass that to this one. Now it will convert that static graph to an interactive graphics. Now you can go, and if you want, you can go, now interactive graphics allows you to communicate with the graph and retrieve much more information. This is very useful if you do presentations. For example, if you just want to focus now, if you just want to subtract this one, here you can use your mouse and the cursor and do whatever the investigations using this. Okay, and if you want to remove this group, and here that allows, just by using a single click you can do it. So you had your static plot, just by passing this to this function, it allows you to convert that to a interactive graph. Okay, so another favorite tool that I use is ggAnimate. Sometimes when you try to present your things in a presentation like this, then maybe you need to attract your audience. You need to have some other things in order to attract the audience. So now this is again, so basically I'm basically in this ggplot extension session, my ultimate goal is to let you know that these things exist. I know I cannot cover all these extensions within a 5 minute or 10 minute, but now you know these things exist and you can go and do yourself research. Okay, ggAnimate is another package that allows you to convert your ggplot outputs in a meaningful manner. So for example, now this is just a static plot. If you want to get, so here basically X, Y, here I basically want to see the CRAN download, number of downloads of this ggplot2 package over the years. So now this allows me to get that information. Now x-axis I want to give the time, y-axis I want to give the downloads, I want to see a line plot, so time series plot. Now sometimes if you want to put that into a presentation, it's good if you can have this type of an animation. Now you can easily apply that type of an animation. Just get the ggAnimate, transition reveal, and along, and then it converts your initial static plot into this type of a plot. So sometimes you might need to install some other packages in order to make it work. But still very interesting. Just by using one single line, you can convert your initial one. And this is another one. Sometimes you will need to think about the transition of the species. I used this penguin data set in my previous demo. Sometimes you want to see their changes over the years. So here you can see it changes the years, 2008 distribution, 2009 distribution, 2007 distribution. You just have to add one more line to make it work, to add this animation layer. Okay, so that's another extension that I used. Then I come to another one, ggRepel. This is again an interesting one. Now sometimes when you give this type of a visual representation, you want to add some text to certain points. You want to highlight certain points, right, depending on the purpose, objective of the visual representation. Now one thing that you can do is you can just extract the points that you want to highlight and you get it into a different data frame and geom text, and then you say, okay, now type the words for this subset, and here you pass the mappings, x and y values. But now when you think about this plot, you can see, okay, now they have marked those values, but it's not that clear. If you just use the ggplot2 functionalities, this is what you get, which is not clear. Now they have done what we have asked them to do. They have marked the values, but not that clear. So ggRepel allows you to do the text annotation in an easy manner. So instead of using geom text layer available in ggplot2, if you use the ggRepel geom text repel layer, now you can see, you can easily, now they have marked it in a very clear manner. Compared to this visual representation, this you can extract information very easily. Okay, so I use this ggRepel quite frequently whenever I write my the journals, publications, and everything. Okay, another interesting one is ggForce. This is also very important. Now, whenever you produce a visual representation, you always need to think about the purpose of that visual representation. We don't unnecessarily overload our documents with plots. You always need to think whether you really need that plot, and then what is the key message that you want it to have. So, so in such situations, sometimes there can be areas where you need to highlight. So in such situations, this ggForce allows you to do that type of things. So now, when it comes to this one, so here this part allows me to create, on these two lines allows me to create my scatter plot. But let's say if you want to give this type of a text annotation, if you want to highlight a subset of that, you can use ggForce. So geom mark ellipse, and then you pass the information. Now it gives me a visual representation with some additional details. So now this is the group that I want to highlight in this visual representation, and you can easily see that. And ggForce 2 allows you to do many other things. Now here, for example, facet zoom is also available in ggForce. For example, let's say this is, let's say if you want to highlight the situation of the COVID period, then maybe you first give the data, the plot for the entire period, and you get a subplot. Here basically ggZoom allows you to zoom in the second layer, basically highlight that specific subset. So likewise in ggForce package, there are so many things that you can do in order to highlight the key message that you want to highlight in your visual representation. Okay, so, and the last one, so I have, yeah, and the last ggplot2 extension that I want to highlight is Esquisse. This is a very easy, very useful package. Now in all my previous slides, I explained how to create a visual representation using ggplot2 API. Now this Esquisse allows you to do it in a very easy manner. Now let's see, for example, if first you need to install the package, I have already installed that one, and then you need to then first basically if you go to the RStudio, first install the package, and then you load the package. And then what you need to do is just take, let's first see this one. Now let's first see. So Esquisse, inside that there is a function called Esquisse, and here I pass my penguins data set. Let's see what happened with this, and then I will show you how to connect your own data set to this tool. Right? So just run this one. Yeah. So I'm not using my computer, so maybe we'll quickly get the Palmer penguin data set. So this is how you can, it's good. This is how you can install your own package. If the package is not available, it says there's no package called Palmer penguins. my data set was inside that package. So in order to install the package, go to packages, install, just type the name of the package. Sorry. As R has auto completion, so this is the package I want to install, so it will take some time. So this, when you install a package, you will get this type of a message, and you have to wait until you get the command prompt. Okay, now I have installed my package to this computer. Now you can so first you have to load that one, and now you just run this one. It will load this user interface. Now this is a very, now you in all my previous slide I explained how to create a ggplot using a data set, using this grammar of graphics. Now this basically allows you to create a ggplot in a very easy manner. So once you load, so basically here I have my function, and here I have passed the data set, and once you load that one, it will load this type of an interface. Now it shows you all the variables that you have. Now here I have x-axis, y-axis. Let's say I want to see the bill length, and for the y-axis I want to have the body mass. And let's say, so now here you can see the graph, the same ggplot2 output, and I want to color them using the species. And maybe if you want to, and if you now you learn facet layer, maybe if you want to get them in a facet appearance, maybe so the theme now minimal, if you want to have them in the dark color, this is what you can get. If you want to, I'll take it as in this one. And if you want to give a color, change the color palette, again it will allow you to do that one. And here in this graph at the moment you have your legend here. Let's say you want to put your legend to the bottom, just select this one. This gives you the legend position to the bottom layer. And then if you want to add a title, so this is basically penguin details. So that is my first title. And then let's say subtitle, let me subtitle 1. So likewise you can give a proper title for the X label, Y labels, and then you can see here you can see the titles. Okay, now you can easily extract, and if you want to extract this graph, here you can download it in multiple ways. And the use of this one is, now if you click on this code, here you have the ggplot2 code. Okay, now the reason for me I actually did not introduce this at the start of the session, because first now you know how to interpret this one. So now if you go and just take this code here, if you just copy this code, and if you run that one, you can just close it, and then here if you run it, here you get the code. And now, so that's what you get. You can take the full control of that one, and you can change the colors whenever you want it. Okay, so that basically allows you to get this type of basic graphs, but if you want to produce maps such things, you cannot do with that tool, but you can easily learn ggplot2 using that aspect. And now let me also show you how to, now here I used this Palmer Penguin package. Now your question is, how can I link my own data set to this type of a tool? So for that you just have to run this one without any data, just run this, then it will open this one. Now you need to link your data set, then it will bring you to this panel. Now here I saved, even if you want to play with the data set, I had already uploaded Titanic data set, very basic data set, but just to get you an idea. Then here external file, you can browse your own data set. So I have saved that in the desktop. So get the Titanic data set here. Now it basically load your data set. Now I want to import that to this. Now it has identified the blue color ones represent the numeric figures, the numeric variables. Here these represent the categorical variables, and name, it's not important for your analysis. For example, if you want age and the fare that they have produced, Now this is how you can get it. And another thing, for example, if you want to see their survival rate, maybe I can put a different color to that. If you want to see the distribution with respect to the passenger class. Now you can see the first class passengers, they have spent a lot of money. The fare amount is very high, that is what we expect, and their survival rate is very high. And if you want to change the color palettes, so here they have used their default color palette. Now let's say I want to put this type of a color palette. Now it has basically taken this color palette. And now if you go and observe the code, here you can see all those things. The minimal, facet wrap, and here they have used this color, Viridis color palette, and here this is how they have done the mapping and everything. So just copy this one and put that into, you can run here and you can take the full control of this one. Okay, so that's basically my large side. So if you want to learn more about these things, you can actually refer these are the main references of this session. So there are lots of things that you can learn. I just try to introduce you to this ecosystem so that you know, okay, these things exist and you can use these things for your research work. Data visualization is very important. Having visually appealing visualization is very important, because then only you can attract the readers. Now if you think about the way you read a research article, for example, once you get a research article, you don't read it from top to bottom. At the very beginning, what you do is you go through the title, then the abstract and the subsection titles, and then you basically observe the visual representations and tabular representations. And that's where you make a decision. You decide, okay, whether am I going to read it further or am I going to remove it. So that's why visual representations are very important. And so because of that, it's good to spend some time and come up with very visually appealing visual representations that will allow you to attract your audience and the readers, and that will allow you to convey your message in a very effective manner. Okay, so that's basically the end of this session. Any questions? I'm happy to take questions if you have, or otherwise you can actually, I recommend you to go to our session website. All these materials are available on the website. If you have any questions after you go through this one, maybe you can contact me. This is my personal website. You can just write to me, then I will be able to respond to those things as well. Any questions? I hope you will use these tools for your research work in the future. Another thing is, sometimes if you are a Python user, now previously there was a war between Python users and R users. The previous discussions were all about R versus Python. But now the things have changed. Now it's no longer R versus Python. Now people talk about R and Python and some other languages, Julia and everything. And now even very recently, RStudio, they changed their name. They changed their name to POSIT. Now RStudio is no longer RStudio. They call it as, the organization is called POSIT. Basically their purpose is integrate all these languages into one platform. So if you go to the POSIT cloud, you can run Python codes and you can run both R codes in a single platform. And we have Coauto. Please go and check out those things. So if you are a Python user, you might think, oh, okay, so most probably you're familiar with the Seaborn package. In Python, we normally use Seaborn in order to do the visual representations. But there's another package called Plot9. Basically, it's a wrapper of this ggplot2 package. Basically, it uses the same functionalities and that is available. The same functionalities are available through the Plot9 package in Python. Okay, so yeah, I hope that information will also be useful for you if you are a Python user. And actually, it's always, all these things allows you to improve your toolkit. So this is not what I do as a research. I'm a statistician by training, and I do research in time series and forecasting and anomaly detection. Those are my key research areas. This is just my toolkit. If you know now, so it's always good to improve your toolkit. It doesn't matter whether you use R or Python or whatever other language. So for example, I always try to improve my toolkit that allows me to do my research in a very efficient manner. And depending on my collaborators, I switch my toolkit. So if I have R users, if the majority of my collaborators are users, then I use R to do the analysis. Then other users can see what I do. Now the research, the open science is a very important thing. People should be able to see your codes, what you have done, then only you can improve the transparency of your research work. So whenever I collaborate with my collaborators, I always check their preferred mode, their preferred software, and then if they are R users, then I switch to R. If they are Python users, I switch to Python. So in my research, I use R and both R and Python depending on the purpose. If I do research related to more statistics related research, I use R. If I work with machine learning, if I do a project on machine learning AI related thing, then I move to Python. And if there are multiple collaborators, then I use Quarto and this POSIT ecosystem so that everyone can collaborate to those codes and everyone can understand what we do. So it's good to improve your toolbox. Then that will allow to take the full control of your research, and that will allow you to do your research in an effective manner. So that's the whole purpose of conducting this type of research, and I hope that you will use these things in your future work. If you have any questions, feel free to talk to me during the lunch break or tea break, or you can even email me if you have any questions after you go through these sessions. Thank you. Oh, one more thing before we go to the, now we are going to have the lunch break. Okay, yes. So now the next thing we have is our lunch break, but before that we have a poster session here. If you look at these things here, you can see multiple posters. We have highlighted different aspects related to research, different tools available in order to do our research in an effective manner. Please go through the research, these posters, feel free to take photographs and go through the content, and after that you can go to the lunch break. Thank you. Yeah.
Good afternoon, everyone. So first I will introduce myself. I'm Suresha Pereira. I'm representing the Open University of Sri Lanka. So I'm a lecturer at the Department of Computer Science. So I'm here not to have a big session with you all. So you have enough 2 sessions, very informative 2 sessions in the morning. So I'll just tell you about what you can see within this room. So there are some posters you can see, as clearly mentioned by Dr. Priyanka. So we have mentioned several things that will help for your research work when you are working with. So during the first session, Dr. Sandun has mentioned very clearly about the literature review, how you can collect your databases initially. So once you have selected your literature research papers, how we are going to work with those research papers. So I'll share one of my experiences. As I have told you, so I'm a lecturer at the Open University of Sri Lanka. At the same time, I am following my PhD at the University of Moratuwa now, and I'm in the year 3, third year student. So when I have started my research journey, there were some confusions with me. How can I manage my literature? There were big confusions. So I was like studying how can I manage those references, within my research journey. So at that time, I was able to like get some of the research management tools like EndNote and Zotero and Mendeley. So you will be asking, what is the best one? There is no one is best. They have unique features. So it depends on your need to select whatever the research reference management tool that you have to select. So there are a few posters with some information relevant to each and every reference management tool, and you can see what are the features available within those reference management software. And also there is a comparison poster, and based on your need you can select. In my research I am using Zotero. It based on my requirement. So it is very easy for me to manage being offline as well as online. I can access my references at any time. So it's my experience. And also those posters were designed not only by myself, and also it's a collaborative work. So it's something like that. So we are collaborating ourselves with everyone. So I have collaborated with Mr. Supun Gautam from the Department of Decision Science, University of Moratuwa. So he will explain what are the tools that we can have within our research journey, how we can represent our research to the scientific community in a visually appealing manner. So normally when we are doing researches, we are just focusing on we are prioritizing on creating very complex algorithms and developing software. But we are not thinking about how we are going to communicate to the research community. Maybe I am working in the data science, and you have to communicate that idea to somebody else in a separate domain. So you have to communicate that in a very simple way to the research community, someone who is in a separate domain. So there are some tools available for the collaborations and also for the note taking and version control. That is very important. For an example, we can go for the GitHub as well. So there are so many tools available. And also for the visually appealing tools, we have Canva, and also we have Graphicto. And so I'm very happy to say that Graphicto is one of the tool came from Mr. Gautam. He is the owner of that tool. So if you have any questions related to those tools, so we are there. So you can ask any question during this session, during the lunch, and anytime. So thank you. So I'd like to invite Mrs. Supun to have a very brief introduction about those tools. Thank you.
Okay, thanks, Suresha. Good afternoon, all of you, and hi, I'm Supun from Decision Sciences, Faculty of Business. So as Ms. Suresha mentioned, we have posters covering few aspects related to research, and some of the aspects that are common for research, as well as some other stuff. Like on this side, we have some posters related to collaborative work, especially if you are working as a research team. Like if you have a group of people working on some related research, like large research work, then there are some tools that might be very useful to collaborate, in the sense like to keep track of which tasks which person is working on and what are the progresses. Or if you are a research supervisor, that might be very useful to track your students, right, on which aspects each of them are working on. And I'll highlight one poster related to version controlling. That is, if you are into computer science, you might be familiar with version controlling. So it is the same concept. That is like if you have research artifacts, let's say things like source codes or documents that gets changed over the time, you will need a way of tracking these changes, right? Otherwise, after a while, you will realize that you have a particular version of, let's say, a document or a project source code, but you have no idea why you made a particular change, right? Or who made that change if you have a couple of people working. So version controlling is a mechanism to keep track of these things as a like a log of a history. So let's say a particular Python code, if you keep changing it, you can track using a version control system like Git, and you will have the entire history in a kind of a log, like a timeline. So at any point you can go back and check who made a particular change, and you can actually put a comment mentioning that let's say part of this file was changed for this particular reason or whatever. So you have a documented history, and you can always go back. Let's say for some reason your code is not working now, but you had a working version like a couple of weeks ago, so you can always go back and take that version, right? So that's the the simplest idea of version controlling. So the most popular tool for that is Git, and you can even publish your repository. So all the artifacts together, we call it as a repository. You can publish it for free on GitHub. So if you want to your artifact to be publicly available for the rest of the world to see, you can create a public repository in GitHub for free, and you can store it there, right? Especially the source code related thing we usually publish on GitHub. If you want, you can even keep it as a private repository, so only you and the users who have given permission can only access it, or you can make it public, right? And the other thing is I want to highlight about infographics. So the infographics has a big buzz these days. It's a kind of a trending topic whenever you want to visually present something. Now we tend to use infographics. Like let's say you have a process that you want to visually show, maybe in your research presentation or let's say in a publication. So rather than just showing it as in a text-based format, you can easily create a infographic like using a tool like GraphicDAO, and so it has a lot of templates that you can select and basically add the content and put some icons or whatever, and change the color themes to prefer your presentation, and basically within few minutes and without even having any design skills, you can basically come up with a top quality infographics so that you can put anywhere, right? Okay, so feel free to walk around and have a look at those posters, and during the break. So we'll be around if you have any questions or anything that you want to get clarified, right? Okay.
A kind reminder, so we will be starting our data visualization camp, our second phase after our lunch. So please back at 2 p.m. So we will be starting our session again at 2 p.m. Thank you.